Hello student, to our web optics course. Today we will going to have lecture number 37, and in this lecture we will going to discuss more about the multi-slit diffraction phenomena that we started in the last class. So, we have lecture number 37 today, and we are going to discuss the multi-slit diffraction. The formalism I already mentioned in the last class, that instead of one slit we have multiple slits here, and the interference pattern and diffraction pattern both going to take place together here. Okay. Let me draw in a different place. That I have these lines here, and light will come from this aperture. There are n number of apertures, and if I place a lens here, and at some point the light will come, not necessarily it will come in a straight path. I am just showing you a crude setup, and it will focus at some point, and this is the P where you are supposed to get the pattern. And we want to calculate what is the intensity distribution, that is I as a function of theta. For single slit and double slit we have calculated that, and for single slit I theta was I naught sine square beta divided by beta square, and for double slit I theta was I naught cos a square alpha sine square beta divided by beta square. That was the structure we calculated in last few classes. Now we are going to extend this idea and try to find out what should be the structure of I theta, what is the mathematical form of the I theta or the intensity distribution for not only one slit but multiple slits. So, these are the opaque space, and in between the opaque space we have slits. These are the slits, not one slits but n number of slits, and we are going to calculate what is the intensity distribution at point P. So, if you remember, we already calculated that EP was E0 then sum over J, that goes to 1 to n by 2, where n is the number of slits, and then two term, one is I1 should be a function of j theta, and another term I2. These two integral we are supposed to calculate. That should be a function of j, and then we need to sum over that thing, where I1 was the integral, it was 2j minus 1 multiplied by a minus b whole divided by 2, and the upper limit was 2j minus 1a plus b divided by 2, and integral was e to the power of I, then k y sin theta dy. That was I1, and I2 was integral, only the limit will going to change, and now we have a minus sign here. So, minus of 2j minus 1a, and then minus of b divided by 2, and this term was minus of 2j minus 1 a plus b divided by 2 e to the power of I k y sin theta dy. That was I2. So, we just need to calculate these two integral, and that is our task today. So, I1 I can calculate, because the integral is in front of us, is simply 1 divided by I k sin of theta, and then this value will be e to the power I k sin theta, and it should be executed in these two upper limits. So, I am writing at a stretch, it should be e to the power of I k sin theta, it should be common, and then bracket I have 2j minus 1 and then a plus b bracket close divided by 2, that is one term, and another term is minus e to the power of I k sin theta, and the lower limit, and lower limit is 2j minus 1 multiplied by a minus b bracket close divided by 2. So, we need to execute this quantity, and that is my I. Similarly, I1, like I1, similarly I2 is something similar. So, it is 1 divided by I k sin theta, usual term, and then this integral will be e to the power I k y sin theta will be executed in these two limits. So, I just need to put these limits. So, it should be e to the power of I k sin theta, and then put this limit. So, first the upper limit, it should be minus of 2j minus 1 a plus b divided by 2, and another term minus e to the power of I k sin theta, and it should be minus of 2j minus 1 a minus b bracket close divided by 2. So, these two terms I execute here. Now, I need to just rearrange few things and then I will going to get. Now, alpha by definition was half k a sin theta, and beta was half k b sin theta. So, that I like to introduce here, because in the integral you can see that k sin theta divided by 2a, this term is present. If I put, then the integral looks simpler. So, if I put this alpha beta, then I1 and I2 will be simply this. I1 will be 1 divided by I k sin theta, and then in terms of alpha and beta, if I write, then it looks simple. It will be e to the power of I, then alpha 2j minus 1, that term will be there, plus I of beta, that is the first term, and second term minus e to the power of I alpha 2j minus 1, and then it should be minus of I beta, that will be I1, and I2 will be 1 divided by I k sin theta, and then e to the power I alpha 2j minus 1, and then I have plus, now there should be a minus sign, minus I beta, now this will be plus I beta actually, and other term will be minus of e to the power of I with a negative sign alpha 2j minus 1 and minus of I beta. Okay, so I1, I2 I calculate. So, but inside that summation we have I1 plus I2. So, I1 plus I2, if I calculate, then it should be I k sin theta, and then from these two you can see that e to the power I beta I can take, in the first case I can take common e to the power I alpha 2j minus 1, so that I can have e to the power I beta minus e to the power minus I beta, and from the second case we can take common e to the power I minus alpha 2j minus 1, and in that case again we get e to the power I beta minus e to the power of minus I beta. So, that thing again we can take common, and if we do so, then essentially what we get is this e to the power I beta minus e to the power of minus I beta multiplied by e to the power of I alpha 2j minus 1 plus e to the power of I alpha with a negative sign 2j minus 1. So, this term will get, and now we can simplify a bit, because now we are in a position to write in a more compact form. So, I k sin theta, this term I write 2 of I of sin beta, because it is e to the power I beta minus of e to the power minus I beta. So, we are going to get 2 I sin beta, that is one term, and this term I can have as 2 of cos alpha 2j minus 1. So, this term contain the j over which we have the sum, that we need to remember. Again, these I can write, this I can cancel, this 2 I can put like k by 2 and 1 b multiplier I can do, and I can write it as b sine of beta divided by beta to get this sine beta divided by beta form, and rest of the term is 2 of cos of alpha 2j minus 1, that term is there, and that is my I1 plus I2. This I will write because I need to make a sum over that over j. So, that is why I will put this term in this way, b sin beta divided by beta, and this term we put 2 I will take outside, and this term I put that it is real part of quantity e to the power I alpha 2j minus 1. Since we need to do the sum over j, it is better that I can put the entire term in terms of exponential rather putting it as a cos. So, cos alpha 2j minus 1 I put in terms of exponential function by writing that real part of e to the power I alpha 2j minus 1. It will help us a lot in calculation. So, then once we have this, so my EP that which I need to calculate is essentially E0 and sum over I1 plus I2. So, it is sum over j goes from 1 to n by 2, and we have 2 of b, then sin beta divided by beta, and real part of e to the power of I alpha 2j minus 1. That is the expression we have. Well, you can see that we need to make a sum over j, and let us do that. So, this quantity is essentially 2b. So, EP turns out to be 2b E naught sine of beta divided by beta, I take it outside, and then I sum, and that will be real part of, when you put z equal to 1, z equal to 2, then I am going to get this I alpha plus 3 I alpha plus 5 I alpha up to n minus 1 alpha. I just put the value of the j to make this sum. Now, this is an interesting looking sum, so I need to first execute that. So, let us see how to do that. So, here if I take e to the power I alpha common, then the rest of the term we have is 1 plus e to the power of 2 I alpha plus e to the power of 4 I alpha and so on, and the last term will be e to the power of I, because I am taking e to the power I alpha common. Then this term will be n minus 2 alpha. Now, this is further e to the power I alpha into 1 plus, if I write x to be e to the power of 2 I alpha, then this term is x, then x square, so on, and this term e to the power 2 I alpha I consider x. So, this term will be x to the power n minus 2 divided by 2. Okay. That will be our last term. So, this is a geometric series, and you can note that there are total n minus n by 2 terms. So, this calculation we can do, this sum we can do easily, and it will be e to the power of I alpha and x to the power n by 2, because number of term is there, minus 1 divided by x minus 1. That will be the sum of this geometric series which we know. Now, let us execute this quickly. So, that thing is essentially e to the power of I alpha and then e to the power of 2 I alpha, which is x, multiplied by n by 2 minus 1 whole divided by e to the power of 2 I alpha minus 1. So, this thing it is as I mentioned, it is a bit lengthy calculation, but straightforward. We have e to the power I n alpha minus 1 all divided by e to the power of I. If I just multiply e to the power, okay, so what, so okay, let me do this step and then 2 alpha minus 1. So, that we have. So, I n alpha, yeah. Now, if I divide these things with e to the power I alpha, so this will be simply e to the power of I n alpha minus 1 whole divided by, if I divide that, it should be e to the power of I alpha minus e to the power of minus I alpha. So, these things is essentially, if I divide that, so it should be cos of n alpha minus 1 plus I of sine of n alpha, that is in the top numerator, and denominator we simply have 2 of I of sine alpha. So, essentially this term is this this term is if I multiply minus I both the sides upper and lower, then it should be minus of I cos n alpha minus 1 plus sine n alpha whole divided by 2 of sine alpha. Now, note that I do not require the entire part of that, I require only the real part of that. If I go back, that this quantity I required the real here, I required only the real part of this sum. So, if I calculate the real part of these things, so real part of the whatever we have, say I put a name here, say this is m. So, I require the real part of m. So, real part of m is simply equivalent to, from the expression it is straightforward, it is n alpha sin n alpha divided by 2 of sin alpha. So, once we have the real part, we are almost there. So, the next thing is to calculate EP, because EP was equal to 2 of B of E naught, and then sine of beta divided by beta multiplied by that quantity, that sum, and that we already execute, and that value is sine n alpha divided by 2 of sine alpha. These two term will cancel out from here to here, and we get even simpler expression, which is E naught B multiplied by sine beta by beta into sine n alpha divided by sine alpha. Now, the intensity at the point P is proportional to the mod square of EP, and with that I can write down the intensity straightway, which is a function of theta, by the way, at point P is equal to I naught sine square beta divided by beta square into sine square n alpha divided by sine square alpha. This is the expression I have, and that expression contains two terms, and here I will mention that this term is the contribution of the diffraction and this term is a contribution of the interference of n number of slits. And the value of beta and alpha, several time I defined, so let me define, it is k by 2 b sin theta and k by 2 a sin theta. That is the expression we have, and this expression and when what is A and B, let me define that if there are multiple slits like this and so on. So, the A is the difference between two successive slits measured from the center point to center point, and B is the individual slit. With these two we define, and based on that we get these results. So, today I do not have much time to discuss more about how the spectrum will look like, how the pattern will look like. In the next class, what we do, that we will start from this point and try to understand that what happened if we plot this function. It will be same like the two slit problem, but here the number of slit is n. So, there will be slight difference in the pattern, but we will try to trace the pattern based on the intensity distribution expression that we derived today, and try to understand more about how it will in the practical field, how it will look like. So, with that note I like to conclude here. Thank you very much for your attention and see you in the next class.